Hello everyone, welcome to KPS. So now we are going to discussing some problems from motion in a straight line. So here the question is, two atoms are falling at a place from heights in the ratio 2:3. Their velocities on reaching the ground are in the ratio. Two atoms are falling at a place from a heights in the ratio. That means heights in the ratio means so they are falling from different heights. Like one of them if you are taking h1 and another one height if you are taking h2, then the ratio h1 by h2 is equals to 2 by 3. And freely falling if you are taking their initial velocities are 0 before reaching to the ground, what is the final velocity that we are going to finding, and as well as the ratio of the final velocity they are asking in the question, v1 by v2 is equals to how much. For that, one of the equations in equations of motions we have to take v square is equals to u square plus 2as. So v square is equals to u square plus 2as, or else v square minus u square is equals to 2as also you can take it as. So initial velocity in case of freely falling body is 0, so we can take v square is equals to 2gh you can take, and freely falling body acceleration a is equals to plus g, as well as height it is h is equals to h we can take. So v square is equals to 2gh, then v1 square is equals to 2gh1, and v2 is equals to 2 v2 square is equals to 2gh2. So v1 square by v2 square is equals to 2gh1 by 2gh2. 2g get cancelled, then v1 square by v2 square is equals to h1 by h2. Already we know that h1 by h2 value 2 by 3. Then v1 square by v2 square is equals to 2 by 3. That implies v1 by v2 is equals to under root 2 by 3. If you remove square one side, then other side you will get root. So root 2 is to root 3. This is the answer for the given question. Next problem. A body is projected with a velocity 60 meter per second vertically upwards. The distance traveled in the last second of its motion is. So we projected a body in upward direction, vertically upward. So we are throwing object vertically upward direction with a velocity 60 meter per second. When you throw it upward direction, it goes up and comes down. So distance traveled in the last seconds of its motion. Last seconds of up, they did not tell asking that last seconds of an upward motion. Entire journey last second, that means it goes up and comes here at this. For example, here to here the time taken is 1 second, and this last second what is the distance it traveled, that we had to find. It goes up and come here before reaching to the ground. Before 1 second we had to find the what is the distance it traveled. So in this situation, last seconds of its downward motion is equals to first second in upward motion. So first second in upward motion, what is the distance it travel? Last second in downward motion, that much distance it will travel to. So first second if you find in upward journey, that is equals to last second in downward journey, you can take it. So from here to here, if you are going to take acceleration due to gravity, if it is goes upward direction, minus g. If it comes down, that is plus g. Now, so we have g value we can take, already they given in the problem. Initial velocity v is equals to 60 meter per second, and acceleration a is equals to 10 meter per second square, that is nothing but a g only. So g is equals to 10 meter per second square, that is acceleration due to gravity. And the time taken, what is the time we are going to check for 1 second, right? So in 1 second, what is the distance traveled in the last second and its downward journey. So we have to take one of the equations from equations of motion. S is equal to ut plus half at square. Then S is equals to u 60 in 1 second plus half a value minus 10 into t square, means 1 square. S is equals to 60 minus in plus into minus, that becomes minus 2 ones are 2 5s are, so minus 5 into 1 is nothing but 5 only. S is equals to 55 meters journey it takes place. So last second in an upward motion is equals to 55 meters. Next problem. A body thrown up with a velocity reaches a maximum height of 50 meters. Another body with the double the mass thrown up with double the initial velocity will reach the maximum height is. Here there are two bodies. One body thrown with a velocity maximum height 50 meters. So if they thrown a body, maximum height it is reaching 50 meters. So we don't know what is that initial velocity that we are taking as u. Reaching to the maximum height means its final velocity is 0. Another body they are throwing with double the velocity, initial velocity of the body, and what is the height it reaches, and its mass also doubled. So final velocity for this one also 0 only. So now we are throwing, if we thrown with a certain velocity it reaching to the maximum height 50 meters. Whatever the velocity if we thrown for this one, this you are throwing double the initial condition. Like if you are throwing here u meter per second, then here we are throwing 2 times of u meter per second it is. If you are throwing, then how much height it will be reached. And here in the problem they mention double the mass. So actually height reaching by the body does not depends upon its mass of the body. And one of the equation from equation of motions we have to take, that is, and as well as maximum height formula if you are taking, h maximum is equals to u square by 2g. G is also constant, its value is 10 meter per second square. So you can take h is directly proportional to u square. Then h1 by h2 is equals to u1 square by u2 square. That implies u1 is equals to u and u2 is equals to 2u, and h1 is equals to 50 meters. Then what about h2? So substitute these all values in this equation. h1 value 50 by h2 we don't know. u1 means u square, u2 2u whole square. That implies 50 by h2 is equals to u square by 4u square. U square get cancelled and cross multiplication if you done. So h2 goes to here and 4 goes to here. 50 into 4 is equals to h2. Then h2 is equals to 200 meters. So here the condition that you had to remember. So what is the height it is reaching by the body if it throw particular velocity? It does not, height of the maximum height of the body does not depends upon mass of the body. From the formula, h is equals to u square by 2g. There is no mass term here to rise maximum height. H depends upon initial velocity, or else what is the initial velocity that we are giving to the object, and as well as acceleration due to gravity. And this acceleration due to gravity is constant, its value is g is equals to 10 meter per second square. This is also constant like 2. Okay. A stone is dropped from a balloon rising up with uniform velocity 9.8 meter per second. If the balloon is at a height of 39.2 meter from the ground of the time of dropping the stone reaches the ground after what time it comes down? A stone is dropped from a balloon, in the sense the balloon you have to consider it is hot air balloon. So somebody dropping from the hot air balloon, a stone is dropping from the hot air balloon, and the balloon is going up with a constant velocity 9.8 meter per second upward direction. Whenever you drop, if the balloon is at a height from the ground 39.2 meters, from here, when the balloon is here, if the dropping the stone and it is going upward direction, so the stone also rises little bit upward, and after that it comes down. So what is the time it is taking to come down to reach the ground? That we had to find. But when the time of dropping the balloon, little bit height it rises, with a speed of 9.8 meter per second. So height of the balloon from the ground is 39.2 meters. And the next one, so what is the initial velocity? 9.8 meter per second, and we had to take that acceleration due to gravity also, 9.8 meter per second square. So now there is an equation to find the time of light. So h is equals to minus ut plus half gt square. In this situation we use this equation to solve the problem. H value 39.2 and u value minus 9.8. So and t that we don't know, we had to find, and half and 9.8 into t square. So now 39.2 is equals to minus 9.8 t plus 9.8 by 2 t square. So 39.2 we are going to write like a multiples of 9.8. That 9.8 into 4 is equals to, we can take common 9.8 from here, then minus t plus half t square you will get. 9.8 get cancelled. 4 is equals to, if you are taking LCM for 2 and 1, then you will get minus 2t plus t square by 2. Cross multiplication, that becomes 8 is equals to minus 2t plus t square. Transpose this 8 from right hand side to left hand side, then we can write this equation, t square minus 2t minus 8 equal to 0. So t square minus 2t, then it seems to be like the linear equation in one variable, minus 4t plus 2t minus 8 equal to 0. So minus 2t splitting, minus 4t plus 2t, that becomes, you will get minus 2t, and if you multiply minus 4t into plus 2t, then you will get so 8t square you will get. So you can take common t from this equation, then you will get t minus 4, and as well as here 2 we can take common, and you will get t minus 4 equal to 0. So from this total term, t minus 4 and t minus 4 is common. Then if you take t minus 4 is common, then rest of the term, in this term t minus 4 is taking common t, and in this 4 if you are taking t minus 4 common, then you will get here plus 2. So t minus 2 into t minus 4 equal to 0. T plus 2 equal to 0, or t minus 4 equal to 0. So t equal to, we can write minus 2, or t equal to 4. So time won't be negative sign. So t equal to 4 seconds. That means the body reaching the ground from here to here within 4 seconds. Next problem. A stone is dropped from the top of the tower, travels 1/4 of the height of the tower during the last second of its fall. The time of fall is, there is a stone dropped from the top of the tower. So we don't know the height of the tower. Actually we are taking that height of the tower is h, and 1/4 of the highest height of the tower is during the last second of its fall. In the last second it is covering 1/4 of its total height in the last 1 second. And we are taking actually total time taken by the stone to reach the ground is time t. Then here to here total time is t. Then what about this one? From here to here, if you are taking the remaining height 3h by 4, and the time taken is t minus 1 second. So t minus 1 second it is covering 3/4 of height, then 1 second it is covering 1/4 of height. So now from this one we have to find the time, how much time it is taking to reach the ground. Time of fall we have to find. So now for total journey, if you are applying that equation, s is equals to ut plus half at square, and it is dropping in the sense its initial velocity is 0. So total height h is equals to 0 into t 0, so that's why we are not representing again, half g t square. This is for total height, and I am going to take 3/4 of height. For 3/4 of total height journey, if you are taking same equation we are going to take. The same equation how you are getting, 3/4 of height is equals to 0 into t. For this 3/4 of height also initial velocity is 0 only. So half g. What is the time taken for 3/4 of time? T minus 3/4 of height, t minus 1 second whole square. So this is equation 1 if you are taking, and this is equation 2. Divide equation 2 by equation 1 if you are doing. That implies 3/4 of height by height is equals to half g into t minus 1 whole square by half g t square you will get. So this equation divided by this equation I am taking. Equation 2 by equation 1. 3/4 of h by h is equals to half g t minus 1 whole square by half g t square. Half g get cancelled and h get cancelled, and the rest of the terms 3 by 4 is equals to t minus 1 whole square by t square. If you remove square this right hand side, then you will get root on left hand side. So root 3 by root 4. Root 3 by root 4. Root 3 is as usual only, but root 4 becomes 2. So t minus 1 by t will get it. Do the cross multiplication. Then root 3 into t is equals to 2 into t minus 1. So root 3t is equals to 2t minus 2. Transpose that minus 2 this side and root 3 2 that side. Take common t afterwards. T is equals to 2t minus root 3t. Then from this one you can take common 2 from entire equation. Then 2 minus root 3 will get. So 2 minus root 3 multiplied by t. Then if you transpose from right to left, then that goes to denominator. 2 minus root 3 is equals to t. We got t value in 2 by 2 minus root 3. So now we are going to this value like a rationalization, denominator rationalization if you are doing. Then 2 by 2 minus root 3 into 2 plus root 3 by 2 plus root 3. So denominator rationalization is nothing but 2 minus root 3 we are taking as like 2 plus root 3. Multiply and divide in numerator and denominator. Then 2 into 2 plus root 3 by 2 minus root 3 into 2 plus root 3. A minus b into a plus b. A square minus b square. That is nothing but 4 minus 3 will get. And t is equals to 2 to the 4 plus 2 into root 3, 2 root 3 by 4 minus 3, 1. Then t equal to 4 plus 2 root 3 will get answer. Okay.